Okay, by the end of this video, we're going to have this animation created in Autodesk Inventor after we can uh, do the assembly with all of these parts. So if you want to see how to do that, you can fast forward to the end of this video. But in the beginning, I'm going to go through and show you how to make each one of these parts. So if you have any defects in the parts, you can always roll back the video to these points, and I'll show you how to make the Geneva gear, also the Geneva drive, as well as the base plate and also the pin this here. So let's get started. For this first part, it does a little bit something different than we're used to. It says if you can find a drawing of a part, you can load it into Autodesk Inventor. Looks like it's loading up another copy. And then what you can do, let's see if I can get over here to this part. Yeah, there is a way to go in here and turn this into a part. So let me go get the instructions from the textbook. And this is hopefully what I can share with you here. So I want to get the detailed instructions and I'll be right back. Yeah, I'm not really a big fan of the blue, but it says we can double click over here and get it over to the standard drawing. And you can see this was probably made in AutoCAD instead of an Inventor, I believe. Yeah, it looks like it was. And so let's go a little bit further in the instructions. I'm just going right out of the book here and begin to turn this into a part. To my surprise, it looks like it's going to be just as easy as making a new part and doing some copying and pasting. So again, with the standard part, this is in chapter 16, so I'm going to go ahead and save that one as the first thing in our assembly. Now it looks like I didn't really go to the right folder. Let's see if it'll let me do that now. Well, didn't really let me do that, but I'm going to save it anyway to the proper folder, not chapter that. 18. You know what? Let me just show you how to do that part then. I'll close all this off for a second. If you're not familiar with how to do this, you go to Manage, Projects, and then you say New, and we have a new single user project. And you can make yourself a folder for each chapter and each project you have in mind. And after you do that, you'll see that it now appears over here, and all your parts from chapter 16 will be here. So let's start that again. See if I can find out where it was. Yeah, right here. So we download that one. And what we're going to do is make a new part. And we'll make it in English units, just like the drawing is. And now we're going to save it again, or save it for the first time, rather. We're in the proper chapter. And since this was an example within the chapter, I'm going to call it 16.0 instead. And this is the gear. So this is Geneva gear that we're making. And it says what you can do is just start your sketch. And I think I'm going to start the sketch on this plane because that looks like the gear is going around that direction. It says all you got to do is come over here and you can double click on this right here and highlight and just copy it. Now, it didn't look like it worked right there. So I'm going to see if I can double click and go back or hit Control Z to undo that. And let me see if it'll actually do it over here instead. Yeah, it looks like it. So I'm going to grab that and just paste it over here. It says, where do you want it? How about right there? Did that center it up? Not so much. And do we have a fully defined sketch? It doesn't really say for sure, but let's just go ahead and try to lock that midpoint right there into the origin. Yeah, that made a mess of it, didn't it? So much for it saving a lot of time. We will actually just go ahead with this, and we could take the time to make it fully constrained. But you know what? Let's just go ahead and assume that all of this is properly done and just start extruding this part. So when we do that, we need to go back and look at the side view of this one. And we see that the side view of this basically says that this bottom plate is 1/2 of an inch, and then we have another 1/2 of an inch there, and then we have a 1/4 inch fillet. I think that's about it. So let's see if that is enough to make it happen. So remember what we do here is we do an extrude, kind of going against my rule of having everything fully defined. That's just because we're kind of in a new realm here and we're copying and pasting sketches from an authority, I suppose. And is it going to make it difficult on us to select these things? Kind of. I guess we can do it that way. And we know that it's 0.5. And then we can say, let's do the hole that's in the middle next. So right there. Okay, that's not so bad. Okay, and then we'll do plus again, and we'll do this one, this donut right here. Yeah, that didn't do it exactly like I wanted it to. Um, yeah, so the order of operations seems like it is going to be important here. So I'm going to try it again, and you'll kind of learn as we go along here. If we do just the outside here, it doesn't exclude those middle parts. I wonder if I do a shift. I mean, yeah, do a shift click. Yeah, I didn't really do it, but that's okay. And we'll go ahead and do the plus sign. And so we'll work our way in. So on this one, we know that one needs to go up by 1. And so this does not need to be a cut, and it needs to go in the other direction. And then finally, we do our cut through the middle. So the order of operations does help you make the part a little bit easier. And then we do fillet, and it needs to be 0.25. And I think we're going to put 1 right there. Is that all we're doing on this one? Okay. So I almost wanted to, remake this part myself, but if you're in a position where you have a drawing file already, you could take advantage of that, especially if it was much more complicated than this. But then the process of making everything fully defined would be kind of crazy. But what we can do is maybe just go back over here and then just kind of suppress those. Should let me right click, suppress, right click, suppress, right click, suppress. And then we want to make this sketch visible. And let's just see how many unknowns are here. How many, yeah, 110 dimensions needed. That's a bit excessive. So that's why and I would think in some cases it's better to remake the part. But the point of this problem was not to do that, but to reuse an existing drawing. So I get what the author of the textbook was trying to do. All right, enough rambling. We will go on to the next part now. Make sure that we save this one. Looks nice. Is there a particular color that we see over here for that one? Looks to be red. So you can select the entire thing like this and go up here to the default. Just kind of look for something that like a light red would be good. And we can hide the sketch to keep those numbers from showing up and hit save. So we're not really ready to make the assembly just yet, but I don't think we need that drawing anymore. I don't think we need this anymore. Next part, still going to be in inches. And for this one, I'm going to use a trick that we've been using in chapter 17, but I'm going to roll those changes forward. Let's see if we can find information about these other parts within the PDF document. So these are basically describing other ways of making the part Geneva wheel, but now we're on to this one here. So what I'm going to do is hit print screen, and I'm going to get just this part right here. And so instead of having to look at 2 screens as I'm making this, I can just save this one to my desktop as 16.0, and this is going to be called the driver, so dash driver. Now, why does this work? Well, because what we can do is start the new sketch, and let's see what plane makes sense. I think this one here is going to make sense on this one. And if we insert that image, it just makes things, I guess, easier to reference. So desktop and this one right here. And I'm going to place it off here to the side like so. Okay, now, um, I guess I could kind of move it up if it'll let me. Looks like it's only let me, wonder if it's right click and move. Let's see, or shift click and move. Yeah, it looks like it's easier to resize this than it is to move it. Oh, there's some even a rotation tool here as well. Let's not go that far with it. Let's just use this as a reference. So we know that the distance between a couple of these points can be set. Like, for example, the height of this thing is 4.5. So I'm gonna pull this up like this so that the top of this, oh, I found out how to move it, um, is right here, and then the bottom of this is 4.5. So let's see if I can say from right there, put a point there, put a point down here, and then say from top to bottom, right there is 4.5. So I'm rescaling the sketch to look similar to what I'm going to have over here on the left-hand side. So we can begin by having just this horizontal line and we'll make this shape. So follow it on, over, down, over, up, then over to the left, down a bit. And before we come back up, we're going to go to the middle of this area here. And we're going to go over here. It looks like it's going to be a 1/2 inch away from the axis. And then we're going to have just, oh, and we're going too far. A little bit cut in, then down. And then once we get here, we can go all the way back home. And that's going to be our axis for our revolve. Okay, so isn't that a lot easier to kind of see this over here, first of all? Remember that this one right here needs to be a center line about which we revolve. So then we can start with saying that this one is, as you can see over here, it's going to be 2. And it looks like it kind of messed up things a little bit, but we can hit escape and pull these over to make it look like it's supposed to. Not too bad, I guess. Wasn't really expecting it to do that much of a shift, but that's okay. So remember that we are able to go to the center line. It's kind of the power of the center line is to get it to give us a diameter rather than a radius. All the way out to the end is going to be our full 6 inches. So click here and then right there, you can type in 6. So we have all 3 of these up here already done. And so we'll go ahead and squeeze in these, the point 1 and the point 1 right there. So from here to there, and the height of this feature. Oh, wait, I think it needs to go the other way. Yeah, so in the process of resizing it, it got shifted around. But now I think we're all good. I normally don't like clicking those middle midpoints, but sometimes it actually works out. And we still got about 14 more dimensions to go, but we know this one right here, I guess from there to the top is going to be a 1/2. I really love doing design. I hope you enjoyed it as well. Kind of relaxing to go through these processes sometimes, creating something new, trying to move this one right below there. This is not really something new. It's more of a scripted exercise, but the principle is the same. Once you have something sketched out roughly, you can put it over to the side and scale it to have like a real world kind of example. As we said, from top to bottom, we can match up our diagram with the one we see from the example, right-hand side. And we don't need this one anymore now that we've rescaled our image to look approximately correct. I'm going to delete those 2 points as well. And so we need 8 more dimensions to go, some of which might be some of the dimensions here. Not sure. We'll start down at the bottom now and go 3/4 of an inch. And then we got this one right here, 0.5 inches. And then from here, I had trouble with this one earlier. It looks like it's working out fine now. 1 inch like that. Let's see. It says we have 5 more to go. So we'll just scan this and see what else we got. I don't see anything else. So we're going to assume that maybe the unknowns has to do with the position of this sketch. So watch what happens when I delete the sketch. You can see now I'm down to 1 dimension on that. So it really wanted us to, fully define that. So to find this last one, we're going to say show degrees of freedom. And you can see that there's something missing right here. So we hit Control Z to bring my image back to see what I forgot. It looks like it's that 2.25 distance that I missed. And because of everything vertical and horizontal, that should be it. And the nice thing about this is if you put that center line in there and work with it that way from the beginning, look at how easy the revolve is. That's it. You are done. So I already made that part for you in just one click like that. There's probably some other things we need to do to this, so let's take a look at those. We need to put a cut out here at the middle, so let's make a sketch on top. Oh, there's also a hole right here. So we'll go 4.5 from, yeah, that's a diameter. All right. So let's put a sketch on top of this plane. Here, right click, new sketch. And let's see. I guess we could just put the pin down here somewhere. And I think it was 0.375. And you see that I purposely did not put it directly on there because I want to line that up intentionally to make it fully defined without any kind of uncertainty. Now we know that the diagonal between those two right there um, has to be 4.5 divided by 2. And then we also want to have this align with the vertical. Now the vertical actually is the x-axis as we see over here. So we're going to say x-axis like this. We want this to align with the center there. Now it's fully constrained. You can punch a hole in it. And that's it. Then we're going to make another sketch on top of this. We're going to start a circle at the corner, or at the edge rather. Go in this far, and I think it said something like 4.5. Nope, 5.25. That was the other one I was looking at. All right, so somebody asked about how to do this one. 5.25. And you see it cuts partially into the other one. So all we have to do is to make that notch in there is to go to extrude. And then oh yeah, I guess just do the cut. And it's trying to make it that way. So we will say click around until it is extruding right through there, making that notch perfectly there. And it should have that little piece left over because that's going to match up with the gear. Let's save that one. Do we already have a name for it? Not quite. So file save as, we're in chapter 16. So 16.0. And this is called the drive, Geneva drive, I think. Do we have all the elements that we need for that? Yes. Oh, it's called the driver. So I was incorrect on that one. That's all right. Now let's make the base plate, bunch of circles. I don't really think it's going to be advantageous for us to do a screenshot, but in the interest of repetition, let's go down here and say 16.0 dash base. Let's just see if it makes things quicker when you go in to this area and say new, standard part, create. It's going to be on the base. So this time we're going to make the two-dimensional sketch down on this area. And we'll pull in this image right there, and we'll just park it up here somewhere. And somehow I got rotated, didn't it? Okay, I didn't anticipate that. Let me try that again. And this time I'll put it in the bottom quadrant to see if that makes a difference. No, it really thinks it got rotated. That's just weird. Can you rotate it like this? Looks like it. So lots of things we're learning today. Um, let's see. It seemed like I was grabbing some corners and it would let me move it. Others would let it rotate. Others would let it resize. Let me try a shift click. Nope. Control click. I know that I was moving this earlier today. And I might have locked it into the origin by doing that. Let's just guess to see if that's the case. So we'll pop that in there one more time. Open. Can you rotate it before you put it in there? No. Okay. So we will just place it in here. And for whatever reason, it comes in rotated. So you can see that we just need a bunch of circles. We need this one and that one, and then one over here. Then we need some lines connecting them, which will eventually be tangent. We'll make them obviously not tangent at the very beginning. And that's about it. So the middle one is 0.5. Hopefully this doesn't shrink it down too small. Okay, it actually shrunk everything down, which is kind of a nice thing, I think. While we're here, do this one, 6. And while we're here, we'll do this one, 7. And you can see that we really need to have this one on the horizontal. So we will use, looks like the vertical is going to be uh, the z-axis. So let's click here and then at the origin. Lines it up pretty good. Then we slide it out here to the left to make it look more like what we have over here. All right. And then, of course, what you want to do is, oh yeah, the separation between those two. I think that says 4.5. Mhm. So from the origin to the center of our circle over there, 4.5. And how many dimensions are needed? How about some tangent lines? So let's use tangent to that. And now we're down to 6 dimensions. And I don't know what the other 4 are. Sometimes these kind of things happen, but you know what? It's probably dealing with my sketch. So let's delete the sketch and see if all that goes away. And indeed, that was it. So it probably had, X, Y, and Z, and then also some rotation, maybe even not Z. This looks good. If I can move that down. There we go. Looking at how to extrude this, you're going to see that we want to leave out this hole over here. So the extrude distance, and this looks confusing because you extrude at 0.375 for this piece. and then you extrude this small circle that amount. So it wasn't really clear when I first read that that was the case. In other words, I guess there, and right here. And it said 0.375, I think. The next bit is going to be 2.75, but then that's the circle, and it'll be up extruded a different amount. So we'll start with a new sketch, and then we're going to train it to find the center by having it recognize the edge and then coming back toward the center. You see the black line, the black dot appeared when I did that, 2.75. And then also we want to raise that up a distance of 625. All right. No, we also need a hole in the middle. Did I not do that? I don't think I put a hole in the middle. So I'm not sure why it's going. Oh, it's my mouse. We need a 1/8 inch fillet, and then also we're going to put a 2 inch hole through the middle. Already by default on 1/8 of an inch, 0.125. We can then make a new sketch and do a 2 inch hole. We go through the whole thing and we're done. Make sure you save this one as base. Looks like I got so busy making the part, forgot to save it. So we're going to save it as base. If we made any mistakes, we can always come back and change those. But let's make this Geneva pen next. So I'm going to save this file right here. Um, as pen. Not sure if this is the best thing to do at all times. Sometimes it's better just to have a piece of paper there in front of you with your notes on what the part looks like. Um, just guessing, I'm thinking that we want to have the part aligned this way, but we'll have the opportunity to rotate it, of course. And make sure that we make this horizontal one right here a center line. Probably waiting too late to pull this one in, but there it is. A little bit too big, of course, maybe. Let's set one of those distances and see if it responds accordingly. Okay, so then we could just shrink this down, grab it a corner. Just doing that thing again. Okay, it does let me move it this time. And looking down at our unknowns, we're going to need to put this one at 375. And this one, oh, I can see why this one is less than, it's going to be less than 0.75 because we want it to slide into a hole, I think. Yeah, or at least it's slot. Yeah, I think it's going to be a slot instead. And look at that. So are we done? If we delete this one, fully constrained, we can zero in on our part like this, and then just say, do it. Then I hit OK and save. All right, do I have all my pieces here? Think so. I think we wanted to make this one green, if I remember correctly, looking at the animation from earlier. Yeah. I don't think we're going to do this blue piece down here. This is an animation from the internet, so we don't necessarily have to follow that one. Our base is going to be a little bit different. It's going to be those two circles. Well, I'll show you in a second. Let's go find something that's kind of just light green somewhere, an indoor pool. Another kind of aqua color. I think you have to select it all again, though, and just scroll around until you get something that hits your eye. I'm sure there is a better way to find colors that are palatable. Didn't mean to do that. It would be kind of interesting to do to make it clear so you could see right through it. But we'll just go with this. And now we're going to start our assembly. And we go down to the second level down here. And let's begin that process. So we're going to place the first part. It's going to be our base. We're going to right click and say uh, place grounded at origin. That way, when we try to move this one, it does not move. Then we will place probably our gear right here. And let's see. I think the kind of construction or the kind of way we want to assemble this is not using constraints, but rather joints. So joint, oh, let's stick with the automatic and orbit underneath this one. And what you want to do is look for, hover over the part until you see a circle with a smaller circle inside. So that one's good. You don't want this. You don't want that. You want it to be just like this. So you see a big circle with a smaller circle inside, then you click. And you say, I want that um, axis and plane to match up with this one. So you don't want this because it's got too many circles. You want it to be just like this. And it'll rotate it into place. And you say, okay. And then if you put it back in the home position, you can see that you can manually rotate this, I hope. Yeah. So although you can't move the base, you can move the Geneva wheel or gear. Uh, Placing the next part in would be probably the drive. Okay, and then open that up, put it right over here. And let's see how we're supposed to do this one. I'm guessing that we need to probably do the same kind of thing. So let's make a joint over here. It needs to be the top circle and a little circle like that. Grounded component. Okay, now that's going to be really okay for us to do, but just so that it's not an issue, let's pick the other part that's supposed to move first. I don't think it's going to be a problem. I think it was just giving us a warning. But basically, it's saying this one's at rest, but we really want this one to move with respect to this one right here. And you can see it didn't even give us a warning in that case. Click apply and cancel. Save this assembly as 16.0 Geneva. And let's see how it looks. Not too bad. And of course, right now, these parts are going to move through each other because we haven't set up barriers or surfaces on which we make contact. Now we get this hole over here so we can put that pin in there, and then that pin is going to go right through that slot. So place, and then grab the pin, and then you see it's oriented incorrectly. So we're going to rotate this about the Z-axis. So right click, rotate about Z. Looks like I got to do it two more times to get it setting it upright like that. And then we're going to make a different kind of joint. We're going to make this rigid because we really want this to be glued. This pin needs to be glued to the green one. So let's select rigid. And again, we're going to go with circle with a small circle inside. And this right here is basically saying that you can set the angle between those two. And that plane represented by that circle has to match up with this plane. So we don't want this one. We want this one right here. I'm not sure what that was at the end, but let's click apply and then see if this thing moves with us. So and that looked good. So it is fixed with relative to this one, but it should go into that slot if we're careful. Remembering that this right here was 0.75 and our gap distance was 0.7. Oh, wait. Oh, I think this one was 0.73 and this one's 0.75. Okay, now, what else do we need to do here? I think there's some other kind of constraint we need to set up here. Um, all right, so I think it's under, let's see, there's some kind of, yeah, we need to do a motion constraint or a motion. Let's go into inspection right here and then activate contact solver. So we're going to say, make it so that these right here, the gear and that pin um, do not pass through each other. In order to do that, you just right click on the part over here in your feature tree and you say set contact or contact set. And then you also want to do the same thing for the pin. So right click and say set contact. So basically you're telling it you don't want these things to go through each other. They shouldn't pass through each other. All right, let's see if that works. And indeed it does. There's your Geneva wheel, made it with Autodesk Inventor. Now what we're going to do finally is make an animation out of this. Um, we could say change the view just a little bit to give it a little more contrast on those edges. Get a little closer view like this. And let's see. I think what we could do is just rotate this one. So what we want to do is find the relationship that basically deals with the rotation of this one. I think there's a way to show those, but what if we just hover over each one? You see that one's at the bottom of the green. This one is a fixed. This is the bottom of the red. So we really want this one and we want to drive it. We want to drive it from 0 degrees all the way up to 360 degrees. And we want to do this multiple times. Let's just say 5 times for our animation. Let's have it go a little bit faster than just slow speed here, maybe 3 degrees per step. That'll make it spin just a little bit faster. We can test it by going forward. So there is 1, 2, and 3, 4. Oh, that's right. Let's put it at 5. All right. So it looks like it's starting out here, calling that the 0 position. If you want to save this movie, then you press this one right here and you save this one to a desktop somewhere. And maybe call it Geneva wheel instead of constraint WMV. You want to change these to make it look better than the default settings, especially if you want to use it in a presentation. Okay, and then so what you do is you play it one time, and then at the end of that repetition, it's going to save your WMV file on the desktop, and I'll show you that it's kind of a low quality. So go like this, going over to my desktop on the other screen. And let's see what it looks like. Here it is. All right, you'll see that it's kind of grainy, low quality, and also cropped it off a little bit as well. Almost looks like a 1970s cartoon. But it's really not that bad of a simulator. It's just that the quality of the video could be better. And that's just me not being careful about the video settings. All right, I hope that helps you make a Geneva wheel and also helps you with the assembly. We got some experience with the constraints. Not so much these. I don't think we did any of the constraints. We did all joints here. And so a joint in this case turned out to be, in my opinion, a flat constraint and then an axial constraint. And so it just does it as one. And I like how it animates it when it brings it in as well. All right. I think that's it. So make sure you save this one, upload it to D2L, and you'll be good to go. I'll see you in the next video.